Okay, let's have a look at the 2017 exam for Algebra, end of year for year 12. This is question 2d. Okay, oops, pencil broke. Okay, it says a computer depreciates continuously in value from this to this over a period of this many years. The dollar value of the computer t years after its value was 4,699 can be modeled by blah. Okay, find the computer's value after 6 years. So the first thing we've got to do is find the depreciation, the actual amount of depreciation. In other words, we know that A is equal to P R to the power of T. That's the standard compound interest formula. This being the initial amount, this being the amount you end up with. And they've written it as this. They've said y is equal to that. I've just said a equals equal to that. But anyway, the initial amount here, it started off at that, ended up at that. So let's write that out. So we've got the initial amount was 1,500. Yeah. Sorry, 490. So the amount we ended up with was 1,500. Here we are, 1,500. And we started off at 4,699 at a certain interest rate that we do not know over a period we do know of 4.25 years. Okay, so that's cool. Okay, sorry, the dog was just trying to get into the room, so I had to make sure she could get out and get in and out. Okay, all right, so what have we got? So first of all, I'm going to find R. To find R, I'm going to first of all dispense with this bit here, divide both sides by 4,699, there it is, it's all gone. So now we're left with this bit here. So let's find 1,500 divided by 4,699. So 1,500 divided by 4,699, and we get 0.3192. So 0.31921685 ... is equal to R to the power of 4.25. So we just have to undo a power of 4.25. Now the way to do that is really, I just put that as a fraction. So that's 4 1/4. So a little sidebar here. If you think, well, what's 4 1/4? That's another way of saying that's going to be 4 4s are 16 and 1 is 17 over 4. So that's R to the power of 17 over 4. If you want to undo that, just multiply it by 4 over 17. So if I was to take this and put that to the power of 4 over 17, that undoes this. But of course I have to do the same thing to both sides. So this is also to the power of 4 over 17, and see where we get. So this should cancel this out here, and I'll be left with R, the interest, well, the rate we're going to use at least, is equal to this to the power of that. Let's go ahead and do that 4 17ths. So there's our answer. We're going to put that to the power of 4 17ths. See if we get what we get. And we get, is that what we want to get? I'm not so sure. Let's have a look. So I would actually, with that, no, oh, look what it's done. It's put the answer to the power of 4 and then divided it by 17. We don't want that. This is the one problem with these calculators that they do. You have to put 4 17ths in brackets. So what we're going to do is we're going to take that amount there and we're going to put that to the power of 4 17ths in brackets. It's a nasty little thing this calculator does. Okay, let's go ahead and do that and see if we can make sense of that. So here we go. So we're going to rewrite this out. So it's going to be all of that there. So let's see if we can do that. So it's going to be, and this time I'm going to put in brackets, so it's going to be 0.31921685 to the power of, and this time in brackets, 4 17ths. Now okay, here we go. So that makes more sense. So this is going to be the amounts depreciating at. So R is going to be 0.764 3888787 ... So that's what we're looking at. So now we've got the R value, which is going to be situated in here. That's our R. So now we can rewrite this using this equation here and using the new R value we have here, which is the amount but it's depreciating by. In other words, each year we're multiplying it by that, the amount we've got left by that amount to get the new amount starting the following year, with. So let's have a look at how we would do that. So the value then, after, and it says what is the value after 6 years. So we're going with 6 years. Here it is. Value after 6 years. How do you calculate that? So let's go back to where we were before. So we've got A, they're using Y, but we're going to use, and I'm using P, I'm using R, and I'm using T here. So A, the value after 6 years, so we're starting off with that value of 4699, here we are, so it's equal to 4699. We've got our rate now, which is 0.764388787 ... to the power of, and this time we know the number of years, and the number of years is 6. So what is that going to come to? And we've got that, we'll have that in dollars. So here it is. So I've got the amount there which we calculated. Let's put that now to the power of 6. There it is. I'm going to multiply that by 4699. And we get $937.32.7. So there's our answer. Let's see how that plays out. So we're going to end up with 900, and this is a dollar sign now, $937, and it looks like I'll put 33 cents, and that's obviously 2DP, so put 2DP. You don't have to put 2DP because it has to be dollars and cents. So value of computer, how do you spell computer? Computer has a P in, by the way. Computer. So put after 6 years, value of computer equals $937.33. And now I'm aware that I left all these DPs in here, and I've been using all the DPs as I've gone through. I've also used the DPs here as well, which means that if you just if you do that, you're going to end up with a slightly different answer to what they do. I'm actually just having a quick peek at their answer. They got 937.26 here, simply because they had rounded this to 3DP, yeah, which is going to make a difference with all those powers. So just be aware of that, but I would keep the number of DPs in as much as you can. Anyway, that is how I would do the answer. Hope that makes sense.